Alright, in this video, let's go ahead and get our player moving. So, our camera angle here is a little hard to see everything. So let's go ahead, we're going to rotate this down a little bit. Pressing, you can do E or use the rotate at the top here, the top tool. I'm going to press W and I'm going to make sure I'm in global mode. And I can just bring that up. There we go. Alright, so for our player, we're going to need a script for our player here. So let's go to our scripts folder. There's a camera script there that comes with the URP. Next, we can go ahead and right-click and create a C# script. And we're going to name this player controller for now. And before we open this, let's go ahead and select our player. And because our player is already a prefab, we can drag this on here, but right after we drag it on, there we go. It's on here, but it hasn't been applied to the prefab. It's applied to the object in the scene, but not the prefab that's in our prefab folder. So all we need to do is select the overrides in the inspector, and we'll click Apply All. Now we can open up our player controller script. And now we can start with getting this set up. So the first thing is going to be putting our variable here at the top. Now, we could do a private float for speed, and this is our variable that we're going to use to control the speed of our player. And if we put private, even if we delete it, it's still a private variable, right? Now, we could also do public, but then that means that other scripts could change our player speed, which we may not want. In fact, most of the time you want to try to avoid doing public. So what we can do instead is we can actually put an attribute here. So if we put our bracket keys, we can put serialize field. So Unity serializes this so that we can change it in the inspector, but it's still private. So other scripts can't change speed, but we can change it in the inspector. So if we save this and we look at our player, once it loads, I could just minimize all of these. Except for player controller, you can see our speed right now is set to 0. So that means for sure our player is not going anywhere. We could go ahead and set that to maybe 50 for right now. And this will override our script that has no value assigned. So there we go, we got our first variable. So our start here, we can delete this comment. We may make one here shortly. So every frame we're going to want to move our player. And so we're going to need to get inputs like our arrow keys and WASD, and then when we get our input, we also want to apply a force that's determined on what keys is the player pushing. So to set that up, first we're going to set up our inputs. So our first input is going to be input.getAxis, and this is set up by Unity already. Unity has the axis set up for us for a few things, and if we put in, you can see our helper here lets us know it returns the value of the virtual axis identified by name. So if we're doing a string of the name, we would put quotations, and then what is the name of the axis? So Unity is the one that has this set up already, so we can type in horizontal. And we can save that for now just to show you. So to actually see where those are at, go to Edit, Project Settings, and then you'll look for Input Manager, and here you can see we have our different axes. So we have horizontal is set up already, vertical, fire 1, so on and so forth. So Unity kind of has these set up already for us, and you can click on them to see their name, which buttons they're using. They have the alternate, which is left and right, and A and D, and the sensitivity. So that's where that's coming from. So let's go back to our script. Now, although we're getting our input for horizontal, in order to use this with movement, we're going to have to assign it to a variable. So you can put equals. So when we get the horizontal input, it is going to be decimal place numbers. So we'll have to create a float, and we'll just call this move horizontal. We'll do the same thing for vertical. Now, we have our inputs that we're getting, and we assigned them to a variable. Now we want to actually use these inputs to control our player moving, either on the X, Y, or Z axis. Alrighty, so to assign that, what that would look like is we're going to create a variable. It's going to be a vector 3, so our X, Y, and Z coordinates, right? We're going to call this movement. And because it's a vector 3 here, we're going to specify this is a new vector 3 variable. And our vector 3 is going to be the X, right, Y, and Z. Now, we can't write it like this, but this just shows you this would be creating a new vector with these components, which it's thinking these are actual variables right now. So what we're going to do for our X, we're going to use our move horizontal. And for the Y, which is actually up and down, right now that's just going to be a 0. And then we have the Z, which is basically going back and forward. We're going to use our vertical inputs, which is like W and S, or the up arrow, down arrow. So move vertical. So we end it with a semicolon. So now we kind of have our movement set in this movement variable. Now to actually, so we get the input is going to control a certain axis. Now we need to actually be able to add force when we use those inputs, which is pretty simple. So we're just going to say, well, first we have to get the rigid body, which, if you remember, the rigid body for the player is going to control the mass and gravity. So what we can do is up here and start, this is going to run one time when we start the game. So we're going to need to get the rigid body that this player controller script is attached to. So we'll just assign this to a variable RB. And in order to do that, up at the top, we can't just write RB here. So what is RB? So this variable, which is going to be private, we're just going to type in the rigid body. So that's the data type. The variable is just called RB. So RB is a rigid body data type. Then we have to get component. Which component are we wanting to get in the brackets here? The angle braces. We're going to type in rigid body. And get component is a method from Unity, so we put our parentheses here, and we put semicolon. So this is kind of like when we want to read, let's say a book. You don't want to have to, every time you want to read a book, you don't want to just have to pull it off the shelf and then read. Instead, you would want to pull it off the shelf and keep it on hand, and then whenever you're ready to read, let's say while you're traveling, you're on a bus, you're at the store, you can just pull your book out of your backpack and read. So that's kind of the idea here, is right when the game starts, we go ahead and get the rigid body so it's ready to go. Then in our update, which runs every frame in the game, we're going to say rigid body. We want to add force, and it's asking for the force and the vector in world coordinates. So we're going to just put in our movement, which is getting the X, Y, and Z, and we're going to times that by our speed variable. That will get our inputs, and then it'll get our speed for how fast we want to go. We can save this now and test it out. And you'll notice on our player controller, you will not see the rigid body variable at all because it's not public and it's not serialized. So the only one that shows up is speed. Go ahead and press play. And here we can see our ball moves. So if I use up arrow, back arrow, and it went really fast. So the other problem that we may run into is because we're dealing with frames and we're moving, if every frame is calculated but our ball starts to move too fast, it might calculate the frame here, but our ball might be moving faster than our frames and be all the way through the wall. Therefore, it could not calculate the collisions. So one way of fixing this would be to control what our max speed would be. So we'll go ahead and grab this serialized field variable and copy it here. We're going to do another serialized field, float, and we're going to name this one max speed. And the ball's going pretty fast. For right now, maybe we'll do 10F. So that's a float number. It's just saying 10, so that means we could be 9.9, 8.5. Be nice and smooth. And then now what we want to do is we're going to write an if statement to look and see if our player is going faster than our max speed. So the way we'd write this is we look at the rigid body and we would look at the velocity. This represents, right, as you read here, the rate of change for the rigid body's position. And then we're going to do dot magnitude, which returns the length of the vector. And then we're going to check and see if that's greater than our max speed. We could put a little note here if we put if the player's current speed is faster than we want. So if that's the case, right, what we want to do is cap it at our max speed. So in order to do that, we're going to grab our rigid body's velocity, the rate of change, and we're going to assign it. The first part is going to be the rigid body velocity, the rate of change, and we're going to use a method here called normalized, and it's going to have the magnitude of 1, and then we're going to times that by our max speed. So that means if our magnitude was to be greater than our max speed, which is 10, it's going to make sure that it can't go higher than 10. Now this is getting kind of messy. We're getting a lot of code inside of update that's making it hard to read. So what we want to do is clean this up and encapsulate our code. And so one of the ways that we can do that is create our own custom method. So the first one, we might call it maybe move player. We have to type in void. It's not returning anything, but this method is move player. Put our parentheses. And inside of move player, we can cut this out, Control X, place it in here, and we have move player. Now, move player will not run unless if we are calling it every frame, telling it to, hey, look for input. So in update, we're going to put move player and then semicolon, so every frame it will run this method. It's like a method inside a method. Now, there's another way of doing this that's maybe a little bit faster. We could select our if statement and our comment, and we right click and we can do quick actions and refactorings, and we're going to extract this to a method. Click that, and then what do we want to call this method? So we're kind of enforcing, a max speed, so we'll call it enforce max speed, all capitals, and then we can click apply. And just to clean this up, I can just get rid of private because it's already private. So now we have every frame of the game, it's looking and calling the move player method and the enforce max speed method, which gives us instructions on enforcing the max speed and how to move the player. So we can save this. And it actually feels even smoother. It's not like zooming across the screen when I go diagonally. Now we can, while we have the game open, we can select our player. And over here you can see our speed right now is 50, so we could test it out just to see, hey, what is 25? Oops. What does 25 feel like? Maybe it feels a little bit better. We're going to do a dash later on where we'll have our player be able to shoot across a specific distance and a jump. So kind of like 25, so we'll go ahead and change this to 25 for now. You notice it didn't save in play mode, but we'll go ahead and save that. And we are good to go. So we'll save our level here, Control S, so we're good. And then our player script, because we made some changes, we can select our player, go up to overrides, and go ahead and do apply all, so it's applied to the prefab.